Hey, hi, good morning, everyone. Good morning, friends. Hope I'm clear. Welcome back to our sessions on convolutional neural network. So, as part of these sessions, we have understood what is CNN. Then we understood what are images, what are videos. CNNs they work on image. Okay, so if you are going to work on images, videos, data, you are supposed to use CNNs, convolutional neural networks. So in the previous session, we have understood the working principle of CNN. We started understanding how CNN works, but we just understood till convolutional layer. So till this part, we have understood. And in this session, we are going to understand what is pooling layer, what are how pooling layer helps, or what exactly does pooling layer does in CNN as part of CNN architecture. Then we'll also discuss what are fully connected layers that we have in the architecture of CNN, and finally the output layer, right? So friends, starting with the comments, we'll quickly recap what we have covered in the sessions in the previous session. Then we'll start the new topics for the day. So we understood image is a collection. Excuse me. Images, we are going to represent them in the standard format. Okay, so that is nothing but pixels. So images will be represented in the form of pixels, and these images are of generally two types: black and white, nothing but grayscale images, and we also have colored images. So under black and white image, we have the range of pixels between 0 to 255, where 0 represents black and 255 represents white. Then, what about the values that we have between the range? You take 100, 200, any value between this range. So, you know, the rest of the values that you have between this range, they talk about different shades of gray color, right? So, we have also discussed the colored images where we have RGB, red, green, and blue as the channels, right? So these are the different types of images that were being discussed, and we understood the architecture of CNN, where we'll have initially the input layer. In the input layer, we'll be passing the image. The image data will be converted in the form of pixels, and it undergoes convolution operation as part of convolution layer. What is convolution operation? Convolution operation is nothing but we apply filters or kernels. You know, we apply some filters or kernels, and these filters they are used to extract the features. Within the image you'll have objects, right? So in order to extract the edges, in order to extract the important information from the objects, from the images, we use kernels, and they are responsible to extract the features. They are responsible to extract the edges, right? And we also use any activation function, like especially ReLU is used. The main purpose of using ReLU is, since ReLU activation function uses the function is defined in this range. It is given as max of 0, x. So when after performing convolution operation, we may get negative values for the output. The output may have negative values. So these values, when they are passed to this ReLU activation function, it makes all the negative values to 0. Okay, and moreover, it is going to add some non-linearity into the model. So this is what we have discussed in the previous session, and today we'll be starting a new topic, that is the next step in CNN architecture. Okay, and moreover, we have also discussed the concept of stride and you know padding. I hope you are aware of the topics. So, friends, if you're joining, for the first time, go and do listen to the previous sessions because this is a continuation topic. Already, part one, as part of CNN architecture, has been explained. It is available on our YouTube channel. Okay, so go and listen to the particular session. Right? So whatever you're seeing on the screen is a convolution operation. Will take a filter and that filter will be slided on the input image. That is nothing but convolution operation, where each and every value will be multiplied to get the output and they'll be summed up. See, right? So the step that this particular filter, when it is sliding on the image, right, is called as stride. Stride is nothing but the step size, whatever the step size that is being used to slide the filter is nothing but stride. Then we also discussed the padding in order to extract the important information which is present at the corners of the image. Okay, at the edges of the image, we use a concept called padding, which helps us to add some additional rows and columns to the original image. Yes. So I hope no questions in the previous sessions. So let us go and understand the next topic, that is pooling layer. Yes. So once after completing of convolution operation, we apply an activation function, that is in general ReLU is preferred. If ever wherever you have the negative values as part of the output that we get in convolution operation, those get converted as 0. So on this output of activation function, we perform pooling. What is this pooling? What exactly happens in this pooling layer? We are supposed to understand, right? Right. So pooling layer in CNN architecture, we'll have next to convolution layer. So next to convolution layer, you'll have a layer called pooling layer. So the activation function, that is not a separate layer, friends. It is part of convolution layer. In convolution layer, you will, initially convolution operation occurs, and next to it, immediately the activation function, ReLU, ELU, or whatever it might be, will be used in order to reduce the feature map, right? So this is not a separate layer. Next to convolution layer, we'll have pooling layer. What is this pooling layer? Pooling layer in CNN, they help us to, reduce the dimensions. Akhil, what is the purpose of reducing dimension? Okay. Assume if you have an image of size 100 cross 100 and I took a grayscale image, okay, a black and white image. So obviously the number of channels will be 1. So I'm not mentioning the number of channels. 100 by 100. This is my shape of the original image. 100 rows, 100 columns. Shape of my matrix, 2D array. So on this original image, on the input data, I have, applied convolution operation where my kernel size is, say, 5 by 5. What will be the size of input? I mean, what will be the size of the output? This is input. This is filter. So what will be the size of my output? Can you please respond? I have also discussed the formula. Assuming stride is 1. Okay. And I did not go and add any kind of, padding. Padding is not applied, assume. So what will be the size of the output image? Input size image is 100 cross 100. Filter size is 5 by 5. Now I am asking you to get, the output size of the output image. Friends, this is very important. N minus F plus 1. What is N? N represents the size of your input image, 100. F represents size of your filter, minus 5 plus 1. So 95 plus 1, it's 96 cross 96. 96 cross 96. So if I take a 96 cross 96 image and if I use it for my fully connected layers, how many parameters I am going to have? Again, more. So in order to reduce the size of this image, height and width, okay, we come and we use something called as pooling. There is a concept called pooling layer in which it helps us to reduce the dimension of your output that you get from the convolution operation. Okay, so on the output of convolution layer, pooling actually happens, which helps us to reduce the dimension of height, width. Excuse me. Okay, so again, the question rises, Akhil, what if, if I reduce the dimension, assume I made it to around, say, 70 cross 70. Just assume. So if I made it to 70 cross 70, all the important information that I have in the original image will be missing, right? So is it a valid operation or not? This is the general question that we get, right? Even though if it is performing the dimension reduction, okay, where the height and the width, the dimension of the image gets reduced, the important information will be retained as it is. Okay, all the important information like edges, the texture, the important features will be retained as it is. So that is the main purpose of pooling layer. Pooling layer helps us to reduce dimensionality. What is the purpose of pooling layer in CNN architecture? A very important question. The purpose of the purpose of pooling layer is to reduce dimensionality of the image. How? That we'll understand. We'll understand that concept here. So in pooling, we have different types of pooling, friends. We have max pooling, min pooling, average pooling, global pooling, and all. There are many types. But understand at least a few types, that is enough. Okay, so see, I'll talk about max pooling first of all. In a max pooling operation, since it is part of pooling, but it is a type of pooling, right? So what I'm going to do here is, this is my output size. I mean, this is the image that I got from convolution layer. Okay, so this is the dimension. What is the dimension? It is 4 cross 4. Am I right? Yes. On the 4 cross 4 image, I'm going to apply pooling. Okay, so what kind of pooling am I going to apply? I'm going to apply max pooling. Let us understand how max pooling works. So initially, we are again going to take a kernel. A filter will be again selected even as part of pooling. Okay, and the pooling, the kernel that I'm going to select is 2 by 2. So initially, a kernel, a filter will sit on the output of the convolution layer. Whatever the output that we get, okay, on the output of convolution layer, we are going to apply a filter of size 2 by 2. Okay, so it goes and sits on the output of convolution layer. What is the size? 2 by 2. So it occupies 2 rows and 2 columns. So out of across all these values, there is This is not convolution, friends. So in convolution layer, the multiplication happens, and then we'll also have the summation done. But this is not convolution operation. This is just pooling, where what type of pooling that you're going to use, accordingly you'll have the output. Okay, so since I'm using max pooling, it identifies it checks all the values that are present in this region where we have the maximum value out of 3, 2, 0, and 7. Which is the maximum value? 7. So 7 will be given as output. I hope it's making sense. Then I'm just keeping the straight as 2. So it leaves the first 2 columns. It goes to the next 2 columns. Here 0, 0, 1, 3. Obviously, the output will be 3. The maximum value across all the values that the filter, the kernel is going to set on the image. In the same way, it comes down. Since I'm keeping the straight as 2, it comes down, and in this region 5 to between 5 to 0, 9, the highest value that we have is 9, and then here it's 3. So this is the output of pooling layer. A 4 by 4 matrix converted to 2 by 2. So see, the maximum values has been written because we are using max pooling. Okay, so this is going to give us the maximum resolution values wherever we have the highest intensity values in the output of convolution layer operation. That value will be written as output by max pooling operation. Okay, a 4 by 4 image got converted to a 2 by 2 image. I hope you got the picture. If you understand max pooling, average pooling, min pooling is very easy. So the name itself is deciding what kind of the output you can expect. Max pooling is resulting the maximum resolution across the shaded region, right? So average pooling will take the average of the values. So if you see here next to max pooling, I'm using average pooling, friends. 3 plus 2 plus 0 plus 7 by 4. So 3 plus 2 is 5. 5 plus 7 is 12. 12 plus 0 is 12 again. So 12 by 4, it's 3. Yes. I hope it's making sense. So max pooling will result as the maximum intensity value, and average pooling is going to take the average of the values from the area where the kernel is going to cover. Okay, can you tell me the next value as part of average pooling here? What will be the value? 0 plus 0 plus 1 plus 3. What will be the output, friends? 4 divided by 4, it will be 1. Then here 5 to 9. 14 plus 2. Right? So 14 plus 2 is 16. 16 by 4 is 4. In this way, it calculates the average of the values. I hope it's making sense. Right? So average pooling will calculate the average value from the area that is covered by the kernel. Now, in the same way, what does min pooling does? Min pooling is going to return the minimum value from the region of the feature map. So within this region, whatever the minimum value that you have, that will be returned as the output for min pooling. It's making sense? Yes or no? Yes. So pooling helps us to reduce the dimensionality by keeping the original features as it is. So if you observe the texture, the edges, the patterns, whatever we have in the original image will not be affected by just because of the pooling operation. Right. Now let me talk about global pooling because max pooling, average pooling, and min pooling are something they are easily understandable. But if you go and focus on global pooling helps us to not just consider only the part that where the kernel is going to cover. Okay. So as part of global pooling, what happens is it takes the entire image. So under global pooling also we have two types, global max, global average. So it takes the entire image. So out of this entire image, what is the maximum value that we have? It's 8. So that will be the output for global max pooling. In the same way, what will be the output for global average? It considers all the windows. Okay, it takes all the values present in the image. Okay, and it calculates the average of these values, and that will be the output for global average pooling. Just one value will be written. Okay, so here as part of global pooling, you'll get only a single value. That's it. Because the entire image, whatever the output that you get from the convolution operation will be considered, and which is going to produce only one single output. It might be global average or global maximum, whatever it might be. When I'm using the word global, it represents all the values present in the image. So this is how pooling is used, and the purpose of pooling is to reduce the dimensionality. So if you observe, a 4 by 4 image is just converted to a 2 by 2 image. So in this way, a pooling layer helps us to reduce the dimensionality, right? So like how many convolutional layers we can have, in the same way, we can also have n number of pooling layers. Okay. We can also have n number of pooling layers. Now, what exactly happens post the operation of pooling layer? Because here onwards, the topic will be again similar to ANN. Sorry. So your input image, which is in the form of pixels, have undergone convolution operation, okay, in which we use filters, we use kernels, to extract the patterns, to extract the features from the images where convolution operation occurs, and to reduce the size. Why do we represent? See, on a single image, obviously I should get only one output, right? See, this is one image. One image is what I am using. Then, Akhil, why did you represent multiple outputs? Why do we have multiple outputs in convolution layer? Friends, what might be the reason? Why do we have multiple images? 1, 2, 3, so on. At least there are 10. Yes. Why do we have 10 images as part of convolution layer? What exactly is returning us 10 frames, 10 outputs in convolution layer? Just think. Yesterday we have discussed this point. Anyways, see, on one input image, are you just only applying one filter? Okay, got it again. So if you apply one filter on your on one input image, you'll get one output frame will be written as convolution layer operation. But if you use multiple filters, if you are using n filters, this n filters will return as n outputs. Okay, it will result n outputs as part of convolution layer. And on each and every output, we apply pooling. It's not mandatory again. See, pooling is applied to reduce the dimensionality, right? So in order to reduce the dimensionality, we are just using pooling functions. So obviously, I'll use pooling technique and accordingly I'll get the output. Once after having pooling layer done, once we have the outputs, we have the frames at the end of pooling layer, what has to be done? There comes a flatten layer. There comes a flatten layer. In CNN, this flatten layer is acting as a bridge between fully connected layers and convolution and pooling layers. Okay, so that means next to flatten layer, you will have fully connected layers. Fully connected layers means, Akhil, we are talking about ANN, right? Yes. So just remember the architecture of ANN. What do you have in ANN? We have input layer, hidden layer, and output layer. How many hidden layers are possible? N number of hidden layers. How many neurons can you have in hidden layers? Again, n number. Right? So, in CNN, this flatten layer, whatever you have at the last, this one, this will act as a bridge between convolution layer, pooling layer, and fully connected layers. So next to flatten layer, you will have fully connected layers. Now let us understand what is the purpose of a flatten layer. Let us go and understand what is the purpose of flatten layer. This flatten layer helps us to convert the multi-dimensional output, whatever that you get here, this output will be converted to a one-dimensional array, a one-dimensional vector, yes. So assuming this is one output of pooling layer. Okay, so this is the output that we got from pooling layer. So this output will be reduced to flatten layer in this way. See, 546, 123, 798. So it represents one-dimensional array. And this one-dimensional array acts as an input to fully connected layers. From here, the actual journey starts, friends. But, next to flatten layer, you'll have fully connected layers, which again resembles the same as the architecture of ANN. But before flatten layer, we understood convolution layer. We also understood pooling layer. So in CNNs, the core component lies in convolution and pooling layers only. Because this is something that is not present in ANN. Why ANNs cannot be used for image data? Why cannot ANNs be used for videos data? The main reason is when you try to use ANNs and see, ANNs for artificial neural networks for image data, what happens? The number of inputs will be more. The number of inputs already discussed. If the image size is 100 by 100, so obviously in the input layer, I should pass 10,000 neurons. Oh my God. So think of the neural network, how complex it is. So that is actually stopping ANNs to
they're why they are not suitable for image data is this is one of the key factor. Key reason why ANNs cannot be used for image data. But what is reducing the dimensionality of this image? Convolution and pooling layer is reducing the dimensionality, and you're going to get the output into a flattened layer, and this output will be passed as an input for fully connected layers. Friends, I hope it's making sense. So here we have an explanation. So what is the purpose of flattened layer is? It is helping to convert a multi-dimensional output, okay, which is in the form of 3 dimensions: height, width, and channels. Okay, so this is being converted to a 1D vector, and this 1D vector will be the input for fully connected layers. Yes. Then when it comes to the input to the flattened layer is typically a 3D tensor. That's what we have discussed. So this 3D tensors will be the input for the flattened layer, where the size will be height, width, and channels. So obviously I'm taking an example 5 cross 5 cross 16. Okay, assume that 16 different filters were being used on the image. Okay, so the output, you'll have it in this way. Sorry, this I just missed is equal to here. My bad. Okay, so obviously you'll have 400 values as the output of flattened layer. So this 400 values will be used as a one-dimensional array. They'll be converted to a one-dimensional array, and this will be used for fully connected layers. Now let us go and understand the concept of fully connected layers, because we are at the end of our story, friends. We reached to the last, we are at the climax, right? So the fully connected layer helps us to process the data. Okay, whatever the values that you get, since your image got converted to finally values, some numbers. So these numbers will be used, and again the same concept. We use weights, bias, activation function, the same journey. Okay, so this helps us to have each layer of the previous layer, fully connected layer, will be connected to each neuron in the previous layer as well, and the output layer of the fully connected layer is computed as weighted sum of the inputs followed by the activation function. The same concept that we have learned in ANN. Okay, so within the neuron, you have summation function, activation function, and you are supposed to finalize the activation function for each and every layer. Uh, in fully connected layer only, you'll have the output layer as well. Okay, so if it is a classification task, yes, ensure what kind of classification. Is it just binary class? So in the output layer, we use sigmoid activation function. And if it is multi-classification task, we use softmax as the activation function in the output layer neurons, right? So the concept is again same. There is no change with respect to the concept. So I hope it's making sense. So I'm just taking the same example. So if you have, the flattened layer will have 400 values, and this 400 values starts connecting to fully connected layer. I'll show you the image so that probably you can imagine how exactly, the values from the flattened layer gets connected to a fully connected layer neurons. This is altogether theory part. Now I hope will be clear. So friends, the entire architecture in one frame, your input image where you have, zebra. This is zebra, right? Yes. So where you have zebra as the image, I mean, as an object inside your input image. So this initially gets converted to pixels, and the convolution operation happens once after, understanding the convolution operation. Once happening the convolution on the input image, then activation function like ReLU will be used to make the output values, if they're less than if we have negative values, it is going to make them as 0. And you know uh, next to convolution operation, we have pooling. See, we have pooling. Then you can use n number of convolution layers. Nothing but, see, I can try using n number of filters, right? So all of them will be part of convolution only. So one filter will capture probably, the horizontal edges. The horizontal edges will be captured probably. But in order to get the vertical edges from the image, okay, see, vertical edges, whatever we have. In order to get the vertical edges, obviously my filter values has to change. Only if the filter values change, the vertical edges will be captured. One filter may capture the lines on the body. So in this way, you can have multiple convolution layers followed by pooling layers. So together they generate feature maps. Okay, so pooling layer helps us to reduce the dimensionality that you get from whatever the images that you get from the convolution operation. In order to reduce the dimensionality, we use pooling layers. So the output of both convolution and pooling layers will be flattened into a one-dimensional vector by flattened layer. So within the flattened layer, you'll have the dimensionality. I mean, it just converts all the values to a one-dimensional array, and the values get, connected to each and every neuron, like how we have it in fully connected layer. So again, this is same, friends. Hidden layer 1, hidden layer 2, hidden layer 3. ANN. Each and every neuron has two functions: summation activation, and so on. And the last layer will be output layer. So this output layer is also part of fully connected layer only in CNN. So if someone asks you what are the layers that you have in, you know, uh, CNN, the answer should be like this: input layer, where we pass the inputs, then followed by convolution layer and pooling layer, then flattened layer, fully connected layer. Okay, so you can also make your answer clear. Within the fully connected layer, I'll have my output layer. Okay, so I assume this is a classification problem where we have horse, zebra, and dog. Okay, so we are going to classify the objects that we have in the images. So what kind of activation function should I use in the output layer? Obviously, it is multi-class, so I have to use softmax. I have to use softmax. Can someone tell me what is the function? What is the formula for softmax? So friends, I'm telling you time again, in order to be clear on the basics, you have to start your journey of neural networks from ANN. Okay. If you are not clear on the topics of, the basics, probably you may or may not grab the concept. In majority of the cases, you may not grab the concept. You'll not understand, first of all. So my sincere request is start from ANN. ANN, we have a complete series of playlist where we have understood what is a neural network, okay, how we train a neural network, what is forward propagation, what is backward propagation, what are the activation functions. You have defined, you also understood the parameters like weight bias. Okay, learning rate we have understood, gradient descent algorithm we have understood, then the types of gradient descent algorithm also understood, right? So if you don't have knowledge on ANN, you will not have knowledge on, you cannot understand CNN, RNN. It might be any neural network, right? Yes, good. The softmax uses a function called, is it seen? Yes, exponential, x power I mean e power xi divided by summation of, e power x, where I takes the values from 1 to n. So depending on the different, classification task, your output, you have to use the activation function. Okay, since it is a multi-class classification, I'm using activation function as softmax, and this softmax helps us to give the values as probabilities, okay, between 0 to 1, and the maximum value that you see here is for zebra, so the output will be zebra. It is going to classify the input image as a zebra class. Yes. Making sense? Okay. So this is the clear understanding of CNN, how it is trained. Okay. So in the next class, probably we'll understand how CNN is applied on a use case. Okay. So same in the output layer. So the activation function will change depending on the use case. Okay. So depending on the use case, we change our output. Fine. So I hope everyone is clear on, the working principle of convolutional neural networks. And in the next session, we'll implement CNN on a data set. Okay, we'll implement on a use case which helps us to classify the images. Okay, so friends, if you feel that the session went well, just hit on the like button before you leave. And moreover, we'll also share one Google form. Feedback link will be shared. Give you a valuable feedback. We'll improve our sessions. We'll enhance our teaching in the upcoming programs as well. And moreover, if you feel that you know that we are communicating some good amount of stuff over the sessions, consider subscribing, because we are coming up with new programs in the future. So in order to get a notification, do subscribe our channel. Right. So that's all for the day. Again, we'll meet in the next session. Until then, take care. Have a great day. Signing off. Bye.